Hi, everyone, and welcome to the first ever episode of our new series, From the Source. I'm your presenter, Ilkka Turunen, Field CTO here at Sonatype, and our other presenter.
Hi, I'm Brian Fox, co-founder, CTO at Sonatype.
So, From the Source is intended to be a bi-weekly show where we'll focus on our special domain, the area of software supply chain management and all the intricacies of that. In each episode, what we're going to do is dive into key topics that includes the latest regulatory updates, best practices for maintaining open source compliance, as well as emerging threats posed by malware, and anything really that kind of affects the life of developers, organization, DevSecOps professionals when it comes to software supply chain management overall. So, Brian, I'm super excited.
Yeah, likewise. I think there's a lot to learn in this space. So you had some examples of some recent malicious types of attacks that happened this summer. Do you want to just give the high level on that?
Yeah, absolutely. So what's been happening over on the JavaScript ecosystem, NPM, is that over the summer, we've observed a huge amount of spam entering that ecosystem. And what's behind that spam is actually really, really interesting. So these are essentially packages that have been designed to look like real open source. They're downloaded by each other. There's sort of bot networks that also stimulate the downloads. And when you crack open the lid and you start looking at these packages, they're kind of nonsensical names. They're kind of published in an automated and sort of flood-like fashion. Thousands of them pop up every single day. What ends up actually being behind it is that somewhere along the year there was a new crypto protocol that was announced called T.xyz to be precise, and it's got some pretty legitimate backers behind it. Actually, one of the people that invented Homebrew, if you're a Mac user, many of us have used that package management system. And what they did was they published a protocol that aims to reward open source contributors. They aim to essentially every time you publish an open source package, you introduce a little token in it, and that token is monitored by sort of the crypto network. And the intention was that if your package becomes really popular, then you get rewarded with a little bit of cryptocurrency. And the idea is, hey, we should compensate our open source maintainers better. Now, of course, this being the realm of software, we can't have nice things. So pretty soon after that was published, bad actors basically overtook that logic and started just publishing outright spam and then manipulating the targets, manipulating the downloads of those packages altogether. So basically they download them from the internet, kind of overinflate the numbers, and that obviously stimulates paybacks for the developers. So over the summer, I think, Brian gave me honest here, we've seen, hundreds of thousands of these sort of appear. And I think I read from somewhere that actually most of the newly published packages over the summer in NPM were basically just spam, that was related to this sort of concentrated campaign.
Yeah. So I think the fact that this is happening highlights a major flaw in the supply chain. Like you said, the motivation in this particular case was for somebody to game the system and get some more payout, to make a bunch of pretend packages look like they're really popular, more popular than real things, and therefore basically steal effectively some of these donations. But I think in order to really understand how we got here, I think we have to take a bunch of steps back. So if we think about how software is developed these days, right? When I started a long time ago, we sat down and started at main void and wrote all of our code from there. Open source came along, and early days, a lot of the open source pieces, especially if you were looking to include capabilities into software you're developing, not open source as in like Firefox or Apache HCBD, where you just wanted to use the software, but like you actually needed a class file or some functionality.
Yeah, like curses to highlight your terminal or something.
Yeah, exactly. And so in those days, you basically had to like go get the source code, and you like would copy and paste it into your software and then massage it and make it work, right? So you were like literally taking a paragraph from a book and putting it into your book. That's how open source largely started in terms of like leveraging the capabilities. Fast forward a little bit, we got to the point where you had whole reusable modules. In Java, these would be the jars, right? In Windows C world, they were lib files, shared objects, DLLs. And so these were whole compiled pieces of unit. So sticking with the book metaphor, it's like taking a whole chapter and including it wholesale into your software, right? And so this made it a lot easier. You didn't have to just cut and paste code. And also, it was easier as those libraries matured and fixed bugs. You just picked up that whole thing and included it. You didn't have to rework the custom code. And then package managers came along. CPAN for Perl was a very early one, but then also Maven, one that I've been involved in for 21 years. Wow, it's a lot weird to say that. Apache Maven is a very popular build system in Java that really modernized some of this dependency management space, basically. And so what happened there was we were able to publish these open source components into a repository on the internet, along with the metadata that included information about the component, but also that component has dependencies too, right? So these are transitive dependencies. And so these repositories in the Maven land, this is what we call Maven Central or the central repository. Turns out Sonatype runs this repository, but other ecosystems followed suit. You have the PyPI, you have the NuGet Gallery, you have NPM.js, Ruby, and Docker.
Packages, and
right.
Dinoland, and all of these other places. Yeah.
That's right. These are the public registries where people can put and share these components. Now, the thing to understand is that most of the interaction with these tools, you add the dependency to your build file somewhere, and the tool goes off and it fetches this automatically from the repository. And then in many of these cases, it reads the metadata and says, oh, I have that thing. I have to get these 15 other things. And it will do this automatically. Some of those ecosystems, that process is actually executing code that's been fetched because they need to be quote unquote installed. RPM is a very well understood thing. It's a very similar thing to RPM where it's actually installing the software.
Yeah.
And in security terms, that's by definition a remote code execution, right? So I think you can start to see where this challenge comes from. Did you want to add anything to that, Ilkka?
Yeah, I mean that's exactly it, isn't it? It's by design, every single modern software build manager, which is in every single programming language, has this built-in remote code execution flaw. And by design, I really mean, in most cases, you need to compile, the library to the right environment. You might need to fetch some extra components. You might need to do some massaging, especially, in these sort of AI projects. You often see the libraries are very sensitive to the target environment. You need to have certain drivers and things like this, so it all kind of works together. And that in itself is pretty dangerous because there is usually no developer interaction. There is no, hey, developer, here's the lines of things that are executing. Even if that was printed out, you could certainly put a -X or something like that on the command line that makes it sort of very verbose. But the issue really is there's fairly little that you can do once the package installation starts. It will compete. And we assume that the package does legitimate things. Now, sort of another fundamental weakness to add on to that exists sort of within the software supply chain when we talk about dependency management is in the upstream, in these registries. Maven Central is a bit of an exception. We kind of take a slightly different philosophy. And I'm sure, the people who like to comment about that will forever have a different opinion. But in places like NPM and Python, in many open source ecosystems, there's sort of a philosophy of, we have open access, anyone's free to register. It's done on a fairly, good intended philosophical background. It promotes contribution back, makes it easy, it lowers the barrier of entry, so anyone kind of can publish a package. It's very easy to do so. But the flip side is, in many places, there is no enforcement or control over the namespace of those packages. So that leaves us open to this sort of field of this sort of risk landscape of people, for example, finding a very popular package and then registering a sort of typo-coded version of it, like changing one letter in the package name. So instead of requests, which is a relatively popular Python package, there's a legitimate malware campaign that was caught using a package name called request. So publish a couple of versions of that, make it, fake the README. It looks perfectly legitimate. And sort of that's combined with the fact that the way that developers actually install these packages in 99% of the cases is they have to type the name out. It's like typing a name, an address onto a postcard, right? So you do npm install requests or pip install or whatever, or mbn install. And so when a infinite amount, there's tens of millions of developers across the world, they do this sort of activity on a daily basis, multiple times a day as well. Eventually, they are going to make a typo. And that's really what these methods of attacks rely on, in many cases when they're using phishing tactics. So in some ways, it's not very different to phishing. We were kind of talking about this in the pre-show, but, sort of all the same gamut types of vectors appear, right? People can do targeted phishing, they can do spear phishing against a single person or a single company, or they can go broad base and use it to distribute malware. And they've really realized that it's quite an effective method of releasing malware. So Brian, we actually kind of keep track of what we're kind of seeing. So over the last few years, I mean, there's been pretty phenomenal growth in these types of attacks as we've seen them.
Yeah, some of the first ones that I picked up on and started, on the conference circuit talking about this problem was way back in 2017. And you could very quickly see the evolution of the attack vectors as each subsequent attack kind of built on the things of the ones before it. But, last year we were at 250,000 known malicious components. This year it's over 700,000. So it continues to double or more every year. We haven't hit that law of large numbers where the percent of growth tapers off yet. And I take this as evidence that this is working. It's working. That's why the attackers keep doing it. Some of these attacks are quite significant. I think we're going to get into some of the different types of attack in a minute. But the reason why, again, that this is happening is that the industry at large does not have good enough defenses against this. And I've been exploring different metaphors. If you think about food at a picnic that's left out too long, that gets maybe a little bit bad. You could think of that like a vulnerability. It might be okay. It might hurt some people who are immunocompromised, but most people are okay. That's like your typical vulnerability. But poisoned food is very different, right? And I think these intentionally malicious components are more like poisoned food. And so the challenge is that organizations try to rationalize this away. They try to handle all of the dependency management problem the same. And they have this mental model of how we deal with vulnerabilities. We prioritize them. We try to fix the most important ones and we'll ship the release. And, it's a big pile. We can't fix them all, right? These are all very valid rationalizations in the vulnerability world. But when you're dealing with intentionally poisoned food, the fix is not go put it back in the fridge. The fix is not eat around the mold. And I think that's the part that's missing, is that so many of these attacks are perpetrated and they execute as soon as the developer downloads them. So by the time you put it in your list and you think about prioritizing the vulnerability, you might have had tens or hundreds or thousands of machines actually, having the payload execute. And we've seen this happen with large, financial institutions that turned this on and started looking for these things and found that they were already baked into applications and deployed all over their portfolio. And so this is a very real problem that not enough people are thinking about. And so, Ilkka, you gave some examples early on. These were they were sort of not super scary from an end user perspective because they were trying to really just steal the crypto, game that popularity system. But let's talk about some of the other types of very real attacks that we've seen.
Yeah, there's been sort of a huge evolution of the types of malware that we're seeing, right? And it kind of follows through, almost mirrors the popularity of open source itself. As it's become more adopted, more ingrained, it's kind of given motivation, and so kind of worse and worse types of creepy crawlies have started to appear. So to your point, like very initially onwards, initially in the beginning, the types of malware that you'd see distributed tended to be things like Discord session stealers. So it was sort of people that were just trying to steal an identity. Often we started seeing crypto miners. Those were sort of the early supply chain attacks that we started observing, where, for example, you saw people distributing just making a package look like it's legitimate, hiding crypto miner in it, developer machines, and highly privileged hardware, usually run on RAM and CPU. So nobody's usually none the wiser. If you get into a CI pipeline, there was at least one heist that we saw that used a vulnerability to poison Jenkins machines, and then mine crypto essentially on those build agents. So initially it was that sort of thing. Dangerous, yes. Criminal, absolutely, but not necessarily sort of dangerous from a sort of resilience and security, organizational security perspective. Over time, though, it started evolving, and we started seeing sort of the more serious gangs appear. Somewhere around, I'm going to say 2018, 2019, we saw the first orchestrated, targeted crypto heist that used poisoned packages, pretending to be open source. And what they did was, actually, this was a takeover attack. They took over an open source project, and they knew that open source project was adopted by a specific crypto wallet. So they poisoned that project. And then when it was running that crypto wallet, actually stole the funds. And I think that group made away with like millions.
And just to put a fine point, I believe this was Event Stream, and it was 2018, I think, and Copay was the target. But the important point here is not so much that it was crypto. I mean, it was important for them. This attack was targeted and delivered a patch file that patched custom code inside of the Copay website, right? Yeah. So that could be anybody's application. If you imagine that these components can apply a patch to your custom code, well, then it's game on, right? And that's the real takeaway, I think, from that Event Stream one. And again, this was 2018 when this happened, and we were out there talking about it. That was a long time ago. But we've seen them all. We've seen it, stealing AWS keys from machines and databases. We've seen some attacks that got into camera streams and things like that at hospitals and police departments and things like this, right? All of these through these dependency types of attacks.
And so you might be thinking, hey, nothing new under the sun. It's all malware that we deal with through all the other ecosystems. Well, what makes these things particularly dangerous, A, is that they're running on privileged hardware that usually have privileged access. And B, it can affect your own code, which means that they're often used as a starting point for more serious multi-phase, or what we like to call them, sophisticated operations, when you see the press releases, right? And so probably the most serious ones that we've seen are legitimate pieces of malware. For example, Cobalt Strike. We found some packages distributing Cobalt Strike a couple of years ago, which I think was sort of an initial warning bell that, sort of the big serious groups have moved into this territory. And more recently, we caught some packages actually distributing Llama, which is a known malware strain. It's thought to originate from sort of Russian nation state originating hackers. Of course, these tools, once they spread out, they get used by other groups as well. But, that's what we associate it with mentally. And kind of interestingly, Llama, the malware family, was amongst the families implicated by Mandiant when they investigated the recent Snowflake breach. So it's actually a really interesting read. We'll add that to the show notes here. But the Mandiant report on the Snowflake breach kind of talks about how they use how they kind of got a hold of Snowflake's authentication tokens and then use those to hack their customers, or kind of hack into the instances and then do what they did. And it was found that the heist started by them distributing infiltrating malware. And one of those strains was Llama. We've seen that same strain happening, being distributed in the supply chain. It kind of makes sense, right? It's something that, developers would have a hold of as well. So unfortunately, this type of more serious, well-funded and well-motivated thing has moved for good into sort of the threat landscape that now faces us as developers. And unfortunately, it's fairly untargeted. I think a lot of these are sort of cast out net types attacks where they do try to typo squat something that's very popular and then distribute the malware. And the beauty of it is for the hackers is, if it hits the developer machine, it is executed. It's almost guaranteed.
Yeah. And one thing, like, while some of those examples you gave are, I struggle to define this, classic malware that might be picked up by your typical, endpoint systems and malware defense systems, things like that. Many of them aren't. Many of them are custom code that is designed to run in the context of the build. So it's not like there's a known backdoor or rootkit that your virus tool or whatever tool is going to pick up and see. That will happen in some cases. But what we're seeing is most of these actually don't look like that. They look like open source custom code that's doing something very fishy. And so traditional malware defense systems are not catching up to this type of problem. And as evidenced by the explosion of them, we're not solving it, right? And so this is something, of course, I was out on the conference track in 2017 highlighting this problem. Of course, we've been working on solutions to this, right? And this is why we're raising the awareness, because we see how many of these packages are. We've gotten really good at identifying them. We have ways of blocking them at the package registry. When your developers are actually downloading these components, and that's really the only way to stop it. You have to stop it before it executes. And again, it's executing as soon as they download it. So scanning before you release the software completely misses the whole war, right?
Yeah, I think that's a really important call out actually in the context of malware, right? If it hits the developer machine or any tool that tries to run an automated build, it's game over. The prevention is the only cure. So, in terms of, and when you add on to that your certain regular endpoint security tools just aren't enough. They don't have this sort of data. It's often custom code. It's deployed once, it lives for a couple of days, then it's removed from the world. They just can't keep up with that sort of volume. So what's pretty interesting is we've kind of inadvertently, become one of the sort of leading authorities in helping our customers prevent this. And we do it by the means of, for example, auditing all of their open source package traffic as it comes in, and then looking for sort of signs of compromise, as well as known malicious and poison packages. And I think at this stage, we're like discovering them, within 10 minutes of them being published. But, sort of technically speaking, if you're thinking about ways of defending this, I think like the couple of takeaways that folks ought to take out of this is A, it's a real hole and it's already there. It's being very actively exploited. And two, prevention is the only cure. Normally, people try to, especially in the context of vulnerability and DevSecOps, we try to avoid breaking builds as much as possible. Everybody's sick of gates. But this is the only place where legitimately stopping a download from completing and breaking a build, sometimes in a fairly violent fashion, is the only way to prevent the payload actually from executing. Unfortunately, these payloads are, so numerous. We've actually collected a timeline of all of these packages that we've seen, sort of the kind of the highlights. We'll make sure to put that on the show notes. But it is a very long laundry list, and unfortunately, it's getting worse.
Yeah, the numbers are getting so big, it's hard to even talk about all of them anymore, which is why we have to move to broad classes of problems now.
Well, that's the evolution. So we're about to run out of time for this first episode. But Brian, it's been an absolute joy to deep dive into this topic. Any sort of takeaways that people ought to take aside from everything we've spoken about?
All the things. Importantly, you can't treat these malicious components like you are your vulnerabilities. There basically are very few ways of solving this. Most organizations have none, right? And so if you think you have a solution for this, I bet you do not. And I see this time and time again. And so people are willingly leaving their front doors open, with the bad guys, trying to come in, thinking that they have defense. And that's the real problem. That's why we're trying to educate people that this is a different problem, requires a different solution that you probably don't already have.
Well, on that depressing bombshell, Brian, I think we're gonna call it here this time. Thanks very much for joining us. Tune in a couple of weeks' time for the next episode of From the Source.